Hello everyone, welcome to my chemistry channel B.Ldash, short and sweet in chemistry. Now the chapter is electrochemistry, short revision in electrochemistry. And the topic is determination of EMF of a cell. EMF means electromotive force, and this is for class 12 and part is 9. And before EMF, we should revise what is electrochemical series, how it is helpful. Electrochemical series is helpful in determining the EMF of the galvanic cell, that is standard condition. Standard electrode potential you should know, then only you can calculate EMF by the help of electrochemical series. In electrochemical series, the standard electrode potential is arranged by the help of standard hydrogen electrode, that is SHE. Then how can you calculate standard EMF? Standard EMF means standard reduction potential of cathode minus standard reduction potential of anode. What is meaning? That means cathode value is higher than anode value, and EMF, standard EMF, that should be a positive. That means standard reduction potential of cathode minus standard reduction potential of anode. Then calculation, how to calculate? First of all, you write the half cell, two half cell reaction in different half cells. That means you will present the half cells, and between that there is a salt bridge, but here salt bridge role is not required. So here only the half cell reaction required, and multiply the half reaction by the suitable number to equal the electron taking part them. Then if you write half cell reaction both, that is cathode and anode, then the electron should be equal. The electron should be equal. How? And according to the multiplication of the by a number, so that the number of electron in both cases, in both half cells, should be equal. And then next is when you will multiply by the number to equal the electron, that should not be multiplied by the standard electrode potential. Then subtract the equation from equation of higher standard. Higher standard mean higher standard electrode potential mean cathode. Then cathode minus anode you will make subtract. Then electrode potential is 0, that means E standard value, or to get the standard EMF of this cell. That means you should know standard electrode potential of cathode and anode. And remember, the standard potential of cathode should be higher than the standard electrode potential of anode. Then only you will get the EM value. Example. Let one example that is zinc half cell and silver half cell. Zinc oblique Zn+2 means this is half cell, where zinc is dipped in zinc sulfate solution. And similarly anode, this part is anode, that means silver is dipped in silver solution. That means here what happened, this part is cathode, this part is cathode, and since in the cell representation this is from left side and this is from sorry this is not cathode, this is anode. So actually the right side which is cathode and left side which is anode. This is anode which has less value, and this is cathode which has higher value, and cathode minus anode gives the EMF value, and EMF always should be a positive one. If it is negative, then it is not representing any cell, not possible, not feasible. So if this value should be given, this value should be given as a standard value of zinc electrode and silver electrode respectively. Now you can see, if you compare both, then which is higher value, that is silver electrode, and which is lower value, that is zinc electrode. Then which is cathode? Cathode should be silver and zinc should be anode. because here zinc is less value. And Ag plus, that means here what happened, if they accept electron, one electron, and to get Ag. Similarly, Zn plus 2 takes receive or accept 2 electron, so that you will get zinc. You can find that electrode potential, standard electrode potential of silver is 0.80 plus, and standard electrode potential of zinc is minus 0.76. That means zinc is less than silver. So silver act as a cathode, this is act as a cathode, and this is act as a anode. And so EMF how to calculate? E cathode, E0 cathode, E0, that means standard cathode, standard anode value. So this is the value where you put and get the EMF. Mind it, here EMF is all, that is here positive one. So this reaction is feasible. The salt is the cell is feasible. So example 2, where the one is zinc electrode, other one is cadmium electrode. So here it is anode side. It is anode side and it is cathode side. That means cathode should be higher value than anode. Find it. Here this is the E0 cell. E0 cell means whole that half cell and half cell when putting by a salt bridge, then E0 cell, that is here you will get 0.36. And zinc plus, then zinc electrode, that is minus 0.76. And here calculate E0 cadmium, that means is standard electrode potential of cathode. You will calculate this one. So what is E0 cell? The value is given, that is 0.36 voltage, and E0 cathode minus E0 anode. E0 cathode, which is here that is zinc cadmium. So it is not given. You should calculate what is the cathode value. So simply you put the value here, that is E0 cell 0.36 plus 0.36 voltage, where zinc is given, that is minus 0.76, cadmium is not there. So E0, the standard electrode potential of cadmium, then it is calculated as this. Now you will get that minus 0.406. Now see, zinc is minus 0.76, minus 0.76, and here that is cadmium is, that is minus 0.40. So what is the less? That is zinc electrode potential is less. And what is the E0 cell? Standard electrode potential of the cell. Means both half cells are involved here. One is cathode, other is anode. Reduction reaction occurs when you observe this all the reaction. The reaction occurs at cathode in a galvanic cell, and a half cell does not work independently. Half cell does not work, but when there is other half cell, then automatically it will work. That means without cathode, anode will not work, and without anode, cathode will not work. So electron flow from zinc to silver, because here from zinc it loses electron to silver, and silver gains electron from zinc. So it is represented as like this: zinc oblique Zn plus 2, and here salt bridge Ag plus oblique Ag. Example 3. E0 cell. Find E0 cell. Then mind it, there are three values mainly. One is standard electrode potential of the cell, standard electrode potential of cathode, standard electrode potential of anode. Now here, what is the value given? See, standard electrode potential of nickel, that is minus 0.25, whereas standard electrode potential here, and that is copper, that is plus 0.34 voltage. Now tell me which is anode, less value. which is less value? Nickel, that is why it is anode. And what is the higher value? That is cathode, that is copper electrode, that is cathode. So here E0 cell equal to EMF. The E0 cell mean that means EM, electromotive force, that is equal to cathode, standard cathode and standard anode. Standard electropotential of cathode, standard electropotential of anode. This is the formula. So you put the value here, that is higher value, that is 0.34 for cathode, and that less value, that is minus 0.25 for nickel electrode. So E0 cell, simply make a subtraction, you get the value, that is this one. What that one? 0.59 voltage. See, it is also a positive one. Positive one means, positive means it works properly, feasible reaction. Find EMF of the cell, whereas there are two half cell given, one is zinc, other one is PB. Sorry, zinc means here from the cell representation, you can say the left part, that is anode, and the right part, that is cathode. That means from the cell representation is there, you can sure which is cathode and which is anode. Cathode means which is higher value, anode means less value. See here, cathode means here minus 0.12 voltage. See here, that is lead. And zinc, which is less value, electrode potential of zinc very less value, that is minus 0.76 voltage. So what should be the first one, which is a higher value? That should be cathode. This is cathode and this is anode. This is anode. So you know higher value, subtract higher value minus lower value. Higher value means cathode, lower value means anode. Electrode potential of cathode, that is lead electrode, here the value is given. Similar zinc, that value is given. So when you subtract cathode, that is anode, you will get the value, that is 0.64 voltage, that is a positive one. So I hope it is clear. Always remember electrode potential of cathode minus electrode potential of anode, and this value should be given in the question. That only simply you put according to the value, the cathode is higher than anode. Then next is example 3, where you can see the cell representation is given CuS/Cu plus 2. That means what? This is standard electrode, that is cathode, that is anode in left side and silver, that is right side. Whether it is correct or not, then you can observe. This is the question given, that means it is sure. But when you see the value, anode value, cathode value given, and cathode is higher than the anode, so you are sure that this copper is value 0.34 voltage, that is anode, whereas that is silver, what value is given 0.80 voltage, that is cathode. So cathode, I told cathode always higher than the anode. Cathode minus anode, electrode potential of cathode minus electrode potential of anode, that is called EMF. Also that is called standard electrode potential of the cell. So simply you will get the EMF by subtraction, that is plus 0.80 minus 0.34 voltage, you will get the value, that is plus 0.46 voltage. Then after that, cell representation and overall reaction. Cell, how to represent? Suppose the question is given only reaction, how can you say cell representation? If cell representation is there, then how can you say what is the overall reaction? and sometimes from the value of standard electrode potential also you can write the overall reaction and also cell representation. Let us the first question. Here cell representation is there. From cell representation tell me what is the cathode. That means left side is anode and right side is cathode. So the left side loses electron that I want to represent in this reaction, and that cathode that is silver, that is cathode where electron is gaining. After gaining electron, and this is the result, but here 2 electron, here how many electron? 2 electron, and here how many electron? 1 electron. To equate the number of electron in both half cell, this is called one half cell. This is one half cell, and this is also other half cell. So after that you make minus one half cell to other half cell, subtract, and this is the result, whereas electrons are cancelled. Number 2, where the cell representation is given, the right side is cathode, right side is cathode and left side is anode. And in this reaction cell representation you can see the left side is zinc and right side is cadmium, and zinc loses electron that is as anode, and Cd+2 accept electron that is as cathode. So in cell reaction you can see here that means you can observe that is 2 electron cancel each other. Here 2 electron, here 2 electron, and the reaction is Zn(S), S means solid, Ni+2 aqua, that means here a representation aqua solution, and it is the Zn+2 aqueous plus NiS. That means here the cell representation is there, cell reaction is there. Then here number example 3, magnesium, that is this is side is anode, and that is cell representation, and this is a cathode. And cell representation where magnesium loses electron, that is Mg+2, whereas silver gain electron, Ag+1 gain 1 electron. That is why to equate electron, this electron and this electron you multiply by 2, and now after subtracting you can get magnesium plus 2Ag plus and magnesium plus aqua, then 2Ag, because here 2 is multiplied in the second half cell reaction. This is the first half cell and this is the second half cell. And now here this example, fourth example, nickel. Nickel is anode. Anode means losing electron, and cathode, this side is cathode, silver, so here gaining electron. Now nickel losing electron Ni+2 aqua, and silver plus, since 1 plus, so we accept that is 1 electron, and this is the half cell reaction 2. Now since the electrons are not equated, and the second equation is multiplied by 2, and here after cancelling the electrons, so this is the that is the net reaction, overall reaction. Nickel S means solid, 2Ag plus aqua, and it gives Ni+2 aqua plus 2Ag S. This is the overall reaction, and this is the cell representation. This is the overall reaction. Then come to fifth example, aluminium oblique Al+3 and salt bridge Ni+2 aqua oblique NiS. That means this is the cathode part. This is the cathode part. When you see cell representation, immediately you can sure that this is the anode. Left side part is anode. Anode means losing electron. See, you are losing electron. This 3 electron losing. Al plus this is plus 3, and similarly this side is cathode, because Ni+2 receiving 2 electron, but these 2 electrons are not balanced. One is 3 electron, other one is 2 electron. How can you balance? The first cell is multiplied by 2, and second cell reaction, half cell reaction, multiplied 3. That means here the electrons are balanced. That means 6 electrons, they cancel each other. And after that, this is the overall reaction. Here Al since multiplied by 2 and 3, Ni plus 2 multiplied by 3, and electron cancel each other, and this is 2Al plus 3 aqua because multiplied by 2, and this is multiplied by 3. This is called overall reaction. From cell representation, one can know half cell reaction, then overall reaction. I hope it is clear to you how to see the overall reaction, cell representation, and how to calculate EMF of the cell by the help of electrochemical series. I hope it is clear. Now, myself B.Ldash, XPGT Chemistry, Kendra Vidyalaya Sangathan. I hope you will subscribe my channel B.Ldash, short and sweet in chemistry.